Hello everybody, hope everyone's doing good. In earlier session, that is in session 2 and session 3, we have discussed few problems related to CAMS. And in those problems, we have the type of follower that was used, that was mentioned was knife edge and roller followers, and the type of motion that was discussed in the problems was uniform velocity and simple harmonic motion. In today's session 4, we will discuss few more problems related to knife edge and roller, and that motion followed by the follower will be uniform velocity, simple harmonic motion, and as well as uniform acceleration and retardation. So let us start with the first problem. It's mentioned here. The follower type is knife edge and it is inline. So when we say inline, it means the axis of the follower and axis of the shaft lie in the same line. Next, we have the lift, that is 50 mm. Lift means lift of the follower, and it is represented by symbol S, that is a stroke, and it is 50 mm. It's mentioned base circle radius is 50 mm, and outstroke with simple harmonic motion for 60-degree cam rotation, dwell for 45-degree cam rotation, return stroke with simple harmonic motion. So here is clearly mentioned the outstroke and the return stroke is simple harmonic motion. For next, we need to draw the cam profile for the same operating condition, that is inline, and also they mentioned draw the cam profile when the follower is offset by 10 mm to the left of the cam center. In the problems what we solved earlier, they have not mentioned the offset direction. So when it is not mentioned, it has to assume it will be on the right side. But in this particular problem, they clearly mentioned the offset is by 10 mm to the left of the cam center. Continuation of this, determine maximum velocity and acceleration during outstroke and return stroke if the cam rotates at 1000 rpm in clockwise direction, and also the direction of the cam they measured is clockwise. So this is the problem. So whenever the problem is there, read it carefully, check whether it's a knife edge, roller type, or it's a flat edge. So it's clearly mentioned knife edge. And also next thing we have to see is the motion of the follower, whether it is uniform velocity, simple harmonic motion, uniform acceleration and retardation, or cycloidal. Here is clearly mentioned is simple harmonic motion. So let us solve the fact to the displacement diagram. Measure 2b and transfer the same to the cam profile 2b. Same way you continue for the remaining transfer, that is transferring from the displacement to the cam profile. After transferring all the points, join all these points by a smooth curve. This represents the cam profile when the follower and the cam axis are in line. Next, as mentioned the problem, the condition is that the cam profile follower is offset by 10 mm and is clearly mentioned to the left of the cam center. Now again, next, to draw this one, again with O as the center, draw the base circle of given radius 50 mm. Now it's mentioned that the offset is 10 mm to the left of the cam center. So measure 10 mm and draw one more circle, that is called as the offset circle. Okay, measure the offset circle. Now draw a straight on the circumference of the offset circle, draw a straight vertical line, and that will intersect the base circle at point M. So that will be the starting point of the follower. Now join M to O. Now with O and M as the base, we have to mark the outstroke, well, and the return stroke as given the values as mentioned in the problem. After marking 60 degree, 45 degree, and 90 degree, again we have to divide the 60 degree, that is the outstroke, and 90 degree return stroke into same equal number of P1 parts as in the displacement diagram, that is 6. After marking that, next we need to draw the line, the points, that is after dividing the 60 degree into 6 equal parts, we have to draw the lines tangent to the offset circle. Remember, it is tangent. tangent to the offset circle. Make sure that the lines that are being drawn goes beyond the base circle. So after drawing those lines, again the same step how which was followed for drawing the cam profile inline, the same we will be doing it here. So next, go back to the displacement diagram. There, measure the distance 1a using a compass. Transfer that distance again to the cam profile by taking 1 as the center and cutting an arc. So that way we have to transfer all the points. After transferring all the points, join all the points by a smooth curve. So this, that is A, B, C, D, E, F, G, H, I, J, K, L. This represents the cam profile when it is been offset by 10 mm. So this completes the cam profile. Next, we need to measure the maximum velocity of the follower during outstroke and return stroke. So to do that, we need to find the angular velocity of the cam, and given by the formula omega 2 pi n by 60, and the value of n is clearly given. It is 1000 rpm. So we have to substitute those values. We will be getting it as omega. Next, we need to find the maximum velocity of the follower during outstroke. So again, we have the formula v naught, that is outstroke, pi omega s by 2 theta naught. So we know the value of omega that we found earlier. Then we know s is nothing but the stroke or lift of the follower. Is mentioned as 50 mm. So remember the conversion, it is 50 mm but convert into meters. After that, theta naught, that is the outstroke. Outstroke is 60 degree and it is in degrees, but we need it in radians. So convert the 60 degree to radians. Then you substitute that in the formula. So we'll be getting the answer. Same way we need to do for the return stroke. So theta r represents the return stroke, that is 90 degree. It is in degrees. So remember that degrees has to be converted into radians. Then we have to substitute in the given formula. Next, we need to find the maximum acceleration of the follower during outstroke as return stroke. And the formula A naught for the follower on the outstroke, A naught equals pi square omega square s by 2 theta naught square. So we know all the values. We know omega, we have found out. We know the s is nothing but the lift, that is 50 mm, convert into meters, and theta naught is the outstroke angle, that is 60 degree. Again convert that into radians and substitute the given formula. So that follow the same question to also for the maximum extension of follower during the outstroke. So this completes the problem. Again, okay, this is the solved one. This is the maximum extension follower during outstroke and return stroke. So this is the answer that we will be getting. Now, if in the problem they mentioned, if here they just asked to determine the maximum extension velocity, but sometimes they may tell to draw the maximum velocity and extension during outstroke and return stroke. Then during that case, we have to draw. That means after doing the calculation, whatever values we get here, that has to be represented pictorially, and that will be done just below the displacement diagram. So read the question carefully, whether they are told to determine or to draw. If it is determined, just draw the right, do the calculation, leave it. But if it is drawn, if they ask to draw the acceleration as well as velocity diagram, then first we need to calculate it. Whatever values are there, that has to be transferred into pictorially, right? So that completes the problem. Coming to the next problem, the mentioned follower type is knife edge follower, and again it is inline. Lift is 30 mm, that is yes. Base circle radius are given 20 mm, and outstroke with velocity, uniform velocity, 120 degree of cam rotation, 1260 degree. Again return stroke with uniform velocity and 90 degree of cam rotation, and well for the remaining period. So as clearly mentioned, the outstroke and the return stroke is with uniform velocity. So as this is with uniform velocity, here you will be just getting a straight line. The displacement diagram will be is that of a straight line from the displacement diagram, that is 1a. Measure 1a from the displacement diagram and we have to bring it again to cam profile with a 1s center, cut an arc. Same way, again go back to the displacement diagram, measure 2b using a compass, again come back to cam profile, now take 2 as a center and make it cut a arc. Same way, transfer all the values from displacement to the cam profile. After doing marking, transferring all the points, join all the points, that is A, B, C, D up to L with a smooth curve. So that will be the cam profile when it is inline. So that completes the problem. Next problem is mentioned. The follower type will be roller follower. It will be inline. Lift is 25 mm. Base circle radius they are given 20 mm, and they mention the roller radius, that is 5 mm. Now there is a difference between knife edge and a roller follower. Here, as it is making use of a roller, we need to as it is as in this particular problem they are making use of a roller. They have given the roller radius. Now that means we need to draw the for this, whenever a roller follower is being used, we need to draw the prime circle. The reason why a knife edge doesn't have a prime circle, because the here in a knife edge and as well as flat face follower, the prime circle as well as the base circle will be identical. It will be one and the same, but not so in the case of a roller follower. In a roller follower, the prime circle will be larger than the base circle by the radius of the roller. So always remember, you should always check what type of follower they measure in the problem. If it's a knife edge and a flat face follower, no issues, there will be no prime circle. But whenever there's a roller follower, there will always be a prime circle. Okay. Next, in the problem, they mention the outstroke, and outstroke with uniform acceleration and retardation. That is for 120 degree of cam rotation, well for 60 degree. Again, return stroke with uniform acceleration retardation for 90 degree, and the well is for the remaining period. They asked draw the cam profile for condition same with the follower offset to the right of cam center by 5 mm, and here cam rotating counterclockwise. So very important, is clearly mentioned in the water problems we have solved so far. The cam was rotating clockwise direction, but here the cam is rotating in counterclockwise direction when the follower is offset by 5 mm to the right of the cam center. So in this particular problem, the type of follower is roller follower. So whenever a roller follower comes, we need to draw the prime circle. Next, it is uniform acceleration and retardation. The follower motion is uniform acceleration and retardation. And one more thing we have to notice here is that the cam is rotating in counterclockwise rotation. So let us see how to draw the displacement and the cam profile for the same. First, coming to the displacement diagram. So the first step is you need to draw a horizontal line. This line represents 360 degree, and that 360 degree has to be divided into the what they measure in the problem, that is outstroke, dwell, return, and again dwell. Now after marking that, again after marking the outstroke, dwell, and return stroke, we have to divide the outstroke and return stroke into again equal number of even parts. So the number of even parts may depend. There is no hard and fast rule that it has to be 6 every time. It can be 4, but 6, 8, 10, 12, but it has to be even numbers. So in this particular problem, they are divided into 6 parts. So divide the outstroke into 6 equal parts as well as return stroke into 6 equal parts. After dividing it, draw vertical lines, and the height of the vertical lines will be equal to the lift, that is S, and it is 25 mm, and complete the box. After doing that, as this problem, the follower motion is uniform acceleration retardation. So here to draw the displacement diagram, we have to, from the center of the out stroke as a distance stroke. Take the center, so it is 3 here, and this 3 vertical line that has to be again divided into 6 number of equal parts. So after dividing the 6 equal parts for both as out stroke and return stroke, if you take the return stroke, here 10 will be the center point, and that has to be divided again 6 equal parts. Next, join O as given here. Join O, that is 0 here. Our stroke starts from 0, 1, 2, 3. So take 0 as the point and join 0 to the 6, that is at the top. Again from take 0 and join it to the center of 3, that is here. Again from 0, that it intersects at 8. Again from 0 to the next point given in 3, it intersects at B, and next you can see that has to be continued. Same way has to be done for the return stroke. So these various points A, B, C, D, E, F, G, H, I, J can be next joined by a smooth curve. So that completes the displacement diagram. So in this particular figure, the center point, that is from the C, 3, they have taken 3 as the center, and center line divided 6 equal parts. They are not named it. We can just name it, give some values, so that will be easier when joining it. After this, we need to draw the cam profile. So the cam profile will be in line. So initially we need to draw the base circle of as the value mentioned. Now, as I discussed earlier, this is a roller follower. We need to draw the prime circle, and so remember, prime circle will always be greater than that of the base circle. Okay, so first draw the base circle with the O as the center. Next, draw again O as the center. We need to draw the prime circle, and the radius of the prime circle will be radius of the base circle, that is 20 mm, plus radius of the roller, that is 5 mm, that will be 25 mm. So again with O as the center, draw one more circle of radius 25 mm. So that will be the prime circle. Now as this particular problem, for the first condition they are in line, so draw a vertical line from O which passes through the base and the prime circle, and such that it touches the prime circle at 0. So with 0 as the center, that is on the prime circle, draw a roller of radius equal to 5 mm. So that is where the follower will be. Next, we have to divide the prime circle. That means we have to transfer the outstroke well and the return stroke on the prime circle. So now taking O and 0 as the base, draw the outstroke, that is 120, then 12, and again the return stroke, that is 90 degree. Again divide this into same equal number of even parts as that of the displacement diagram. Now extend these lines beyond the prime circle. Extend these lines beyond the prime circle such that it intersects the prime circle, and you can mark it as 1, 2, 3, 4, 5, 6, 7, 8, and so on up to 12. Next step is we have transfer the points, transfer the values from the displacement diagram again to the cam profile. So to transfer it, again go back to displacement diagram, measure 1A, and with 1 as the center, that is 1 that will be lying on the prime circle, cut an arc. Same way, measure 2B from the displacement diagram, come back to the cam profile with 2 as the center. This 2 will be lying on the prime circle. Remember, prime circle with 2 as the center, cut an arc. Mark it as B. Same way, we have to mark all the points. Now, after marking all the points, those points become with here if needed, as in the earlier problems we have drawn the prime circle, we have drawn the pitch curve, right? Now these points A, B, C, D, E, F, G, H, I, J, K, L, all these points can be joined together by dotted lines, and that becomes the pitch curve. But in this particular sketch, in the PPT, they are not joined it, but we have to join it. Join A, B, C, D, F, G all together by dotted lines by smooth curve, and join it to O. Join it to that point 0. So that becomes the pitch curve. Now once after drawing the pitch curve, now with A as the center and the radius equal to that of the rollover, draw the circles at different points A, B, C, D. We need to draw circles, and circle radius will be equal to that of the rollover. Once all the circles has been drawn, join the bottom of all the circles by smooth curve. Join the bottom of all the circles by smooth curve. So that curve, this curve is what we call as the CAM profile. So this completes the CAM profile when it is inline. Next, they have mentioned that follower is offset, and they also mentioned it is right of the CAM center by 5 mm and rotating in counterclockwise direction. So the procedure is same. First we need to draw the base circle. After drawing the base circle, we need to draw the prime circle. Now here is mentioned that offset is 5 mm. So draw an offset circle with O as the center and radius equal to 5 mm. Now from the circumference of the offset center, draw a horizontal line, straight horizontal line, and such that it passes through base and the prime circle. So mark at the point on the prime circle, and that is M. Now join O M. Join O M. Now with O M as the base, we need to draw the outstroke, dwell, and the return stroke. And remember, it's clearly mentioned in the problem, it is rotating in counterclockwise. Whatever problems we have solved so far, it was in clockwise direction. So we always started from the left side. That is the outstroke, return stroke. We used to always transfer from left side, but it is in counterclockwise, so we have to start from the right. Right. So that's the reason. Take OM as the base and transfer the outstroke values. That is 120, dwell, and the return stroke. Again, the same process. We have to divide the outstroke and return stroke into equal same number of even parts as that of the displacement diagram. After dividing it, extend the lines so that it crosses beyond the prime circle. Next, again, wherever and make mark 1, 2, 3, that is on the prime circle wherever the line cuts through it. Next, we have to transfer the displacement diagram value, that is 1a. Here measure it by using a compass and come back to the CAM profile. Here again take 1 as the center and transfer the distance, that is mark 1a. Same way do it for 2a, and with 2 as the center, cut an arc aside, mark it as b. Same way we have to mark the remaining values, that is c, d, e, f, and up to k, l. Right. Next, after doing that, again we need to, here is not shown in the sketch, but we need to join all the points, that is a, b, c, d up to l, and we have to continue and we have to bring it to join to m. So that becomes the pitch curve. That is the pitch curve. Next, we are taking A as the center. We need to draw the roller for various points of A, B, C, D, and the roller radius will be equal as measured 5 mm. Right. We have to draw the rollers for all the points, that is from A to L. Next, join all the bottom of the rollers. Join the bottom of the rollers by a smooth curve. So that curve is the CAM profile. So this is how we need to draw the CAM profile when it is offset, and offset is rotating counterclockwise direction, and the roller here being used is follower we are using is roller type. Okay, so we'll end the session today with this problem. So I request everyone to back to do it by using in your notes or paper sheets. Follow the instructions given. If any doubts, please call me at any time or let me know if any doubts are there. Thank you.